about 300 BCE or BC, whatever you want to call it. Okay, so that's about 2,300 years ago. If you're interested, I'll show it to you at some point. But it's a great argument. It kind of also shows you how to teach. You know, that's what mathematics is all about. This guy said, how can I show that I cannot write it as a ratio of two integers? You know, there are infinitely many, in fact, doubly infinitely many combinations of integers you can have, right? I got to be able to show it for all of them. No, you don't have to. He starts with the argument, let's assume that we could, okay? Then there must exist two integers where if you square that ratio, it's equal to 2. You know, I'm not going to go over it, but if you uh, go with that argument, both the numerator and the denominator of that ratio has to be even. Well, if it's even, then I can write it, reduce that. But then using the same argument, it creates an infinite loop. There is a limit to, you can reduce ratios. You cannot reduce 1/2 anymore. 2/4 is equal to 1/2, but 1/2 is not equal to any other simplified ratio. By showing that, assuming that the thing was incorrect, the theorem was incorrect, led some logical absurdity. In fact, in Latin, you call that reductio ad absurdum. You know, you basically assume it's not correct, follow its logical conclusions. If it creates some sort of absurd result, by definition, what you assume to be wrong must have been correct. But we're not going to deal with any of these. Here's what we're going to do. Let's go to our spreadsheet. Okay, I'm going to kind of create a little template. First, I'm going to calculate. I'm going to create a template that's going to calculate to me either present value of a future amount or future value of a present amount by using clever use of a little checkbox. All right. First and foremost, I have some conventions. When you do your own spreadsheet, use whatever convention you want. But these are my spreadsheets. If you don't like the way I color things, tough luck. When you download the spreadsheet I post, you can change the colors the way you want. I make a distinction between inputs and outputs. What are my inputs? I'm going to have, in fact, I'm going to call this, let me use the keyboard on this. Because my other keyboards is having issues. I'm going to call this annual percentage rate. Let me put these here. And for now, I'm going to put 5%, not 55. You may have noticed that I wrote that as 5 and percent sign. Internally, you're telling Excel that you got to convert that into a decimal, which is 0.05. And it also formats it as a percent cell. But I could have written that as something else. Under Home tab, right here is number formatting range. Click on percent. I like some digits on my percents. Left arrow adds digits. Oops, I got hashtags. Who knows what those hashtags are? Yeah, the column is too narrow to contain the numbers, to display the numbers the way I want it displayed. Click on the column, double click, it auto fits. Okay. Uh, there's a good reason you should have some extra digits. Nobody ever died because they had some extra displayed digits in Excel. But I've seen a lot of students die on a question because they had that percent as a whole number. Sometimes I ask you a question, find the yield to maturity in a bond. The answer is 6.12%. If you don't have extra digits, it's going to show up as 6%. And being the diabolical asshole that I am, 6% is one of the answers in that multiple choice. You're going to jump on that and you'll be mine. All right. Again, nobody ever died because they had too many digits. And in general, don't round things up too much, especially if you're doing multiple calculations. Uh, mm, this is in computer programming, it's called round off accumulation. If you round off intermediate results, after a while, they kind of accumulate the error. Okay? So put everything, I mean, if you're doing everything in Excel, that doesn't matter because internally, whether I show 4 digits or 1 digits, it's exactly 0.05 for Excel purposes. And nice thing about formatting them as Excel, you don't have to remember anything about how to write that as a decimal. It's a useful skill, but it's basically not that important. Who's going to tell me what 0.05% decimal representation is? 0.05%. Basically 0.0005. But who cares? If I want to write that, that's what I write, 0.05%. Oh, if you're writing it like that, if the leading number is 0, you have to write that 0, because otherwise it thinks you're writing a decimal. Or the answer is 275, just write 275. That's the benefit of percent representation in Excel. You don't have to know anything about that decimal representation. Who cares? I mean, I have that ability to do it, but does that make me any better than you are? No. Okay, whenever I have something as an input, I like coloring that background green. Of course, I'm using my Welsh green. If you want to know, it's the hex code 00B140. Hex is short for hexadecimal. You guys probably don't even know what a hexadecimal number is. All of our calculations are on base 10, right? We have numbers 0, 1 through 9. Then we have 10, 11, 1. In base 16 or hexadecimal, you have 0 through 9, then you have A, B, C, D, E. E in hexadecimal is equivalent to 15 in decimal. So at my later ages, I started reporting my age as a hex number instead of decimal number. So I'm currently, let me see, 3C years old. The first digit is the 16 to the power 1. So I have 3 of those. 48 plus 12. 12 is equivalent to C in hex. All right. And I like making my inputs bold. And I'm going to make that white. I said annual percentage rate on purpose. I'm not simply calling it interest rate because all the interests are quoted as APRs, which is basically, let's say you borrowed where the so-called compounding is monthly. That means the interest is calculated every month. And actual interest rate for that month is APR divided by 12. Okay, so there's a compounding frequency. I'm gonna call that 12. If it's monthly 12, weekly 52, daily 365, quarterly 4, how many periods of that kind are there in one calendar year? That's what that means. Boom, boom, boom. From that, I can calculate period interest rates. In Excel, I know you guys took Excel class, but I'm going to repeat it anyway. Any formula starts with an equal sign. That tells Excel that whatever that follows is a formula. I'm going to refer to the annual percentage rate, which happens to live in the cell that's tagged at 4. Divide that by compounding frequency, which lives in the cell F5. Now, the references like that are called relative references. If I copy that formula and paste it just to the cell below, that formula is going to paste as F5 divided by F6. A lot of times, that's a very convenient thing to do. I don't have to rewrite all those formulas. But sometimes that is not what you want to do. Sometimes you want to fix them. You can do that as an absolute reference. For example, I'm going to do that for interest rates for now, or I'm going to do that for compounding frequency. If your keyboard has the F buttons functions, that's F4, it converted it into $F, $5. Those $2 have a specific meaning. The first dollar says, when you copy this formula and paste it somewhere else, fix the column reference. Keep the column reference as F. So if I copy this formula and paste it under column M, it's still going to paste it as column F. Okay. The second one is whether or not I want to fix the row reference. In fact, you could even keep one of them fixed, make the other one relative as well. Sometimes if you're calculating something on a table, let's say you have interest rates on the columns, you have years on the rows, and for each you want to calculate uh, the value of $1 you're going to get in that many years. Okay. In fact, we had tables like that before Excel became everywhere. They were called present value factor tables.